The Pythagorean identities are a set of three identities that come from using the Pythagorean theorem on the unit circle. So what I mean by that, if we look at any point on the unit circle, like in the picture, we know points are x, y points. We go over x, up y to get to that point. So we can use this right triangle. Well, based on the Pythagorean theorem, we know that x squared plus y squared equals 1 squared. Well, and 1 squared is just 1, so we can go ahead and take the square off that. We are just using this Pythagorean theorem, but subbing trig terms in for it. And what I mean, if we look at this xy point, we know that x is the same as saying cosine of theta. We say that this angle is theta. Y is the same as saying sine of theta. So instead of using x squared plus y squared equals 1, the Pythagorean identity says that whatever cosine of theta squared plus sine squared of theta always equals 1. So this is your main base Pythagorean identity. Cosine squared plus sine squared equals 1. That may seem like a strange equation to always be true. So just to give you a little example of how that can work, let's say we plug in pi over 6 for theta. Well, test this out. If we do cosine of pi over 6 and square it, quick side note, when that square on the inside is the same as saying sine of theta with a square on the outside. These are equivalent, you can write it either way. Anyway, so if we look at cosine of pi over 6 squared plus sine of pi over 6 squared, let's see what it equals. So if we use our unit circle, we know cosine of pi over 6 is root 3 over 2. We know sine of pi over 6 is 1/2. Well, root 3 squared, distribute that square, becomes 3/4. 1/2 squared becomes 1/4. 3/4 plus 1/4 equals 1. So just one side example that this is just a true statement no matter what. Cosine squared plus sine squared always equals 1. So that is your base Pythagorean identity. We can build all the others from that. And what I mean by that, we have two other versions of the Pythagorean identity. So for both of them, we're going to start out with this cosine squared theta plus sine squared theta equals 1. I'm going to write that twice here. The way we can build the other two is if we divide both sides of the equation by cosine, or if we divide both sides of the equation by sine. So first, essentially that's our first Pythagorean identity. To get the second one, we're going to take this base equation and go ahead and divide out cosine squared from every term of the equation. Essentially dividing both sides of the equation by cosine squared theta. Since we're dividing both sides by the same thing, this will still give us an equal equation in the end. So as we do that, well, cosine divided by cosine just equals 1. Sine squared over cosine squared, if we look at those quotient ones, identities from the slide in your notes, just equals tangent squared theta. And then 1 over cosine squared theta, if you use your reciprocals, equals secant squared theta. So that's your second Pythagorean identity. Now for the third Pythagorean identity, same idea. We'll just divide sine out of everything. And if we divide everything by sine, cosine over sine, if you use the quotient identities, is cotangent. Sine divided by sine is 1. 1 divided by sine is cosecant. So that is your third Pythagorean identity. So you will not have to derive these every time by any means. This is just so that you can see where they come from. Your three Pythagorean identities are your squared identities here, and they'll work just like the reciprocal and the quotient identities. They are just facts that are true. It's like me saying 1 plus 1 equals 2. Cosine squared plus sine squared equals 1. These are just facts of trig. So make sure in your notes you have all 4 sets of identities written down, big box around them, quotient identities, reciprocal identities, the negative angle identities, and these Pythagorean identities. You will be expected to have all these memorized, as they'll be imperative as we work with verifying identities as well as trig equations.